Okay, guys, welcome. Today we're going to talk about the two basic trig functions. We're going to talk about cosine and sine, which is usually what we start with when we talk about basic trig. We're going to talk about how to find the sine and cosine of 30 and 45 degrees, and any multiple of those. And of course, we'll also talk about how that relates to pi over 6 radians and pi over 4 radians. We'll talk about whether cosine or sine of an angle is positive or negative. And we'll talk about how you can find what the radius of an angle is when you're given either cosine or sine. And then we'll talk about finding cosine and sine if you're given one and the quadrant of where the radius is. Okay, so just as a refresher, we've talked about things so far where we're taking angles and we're looking at the corresponding endpoint of their radius on the unit circle. All right, and here's a couple examples of those. Now, if you're given an angle without units, we're going to assume that the units are in radians. Okay, now you have to be careful here because most calculators are preset to radians, but at some point you may have transferred it to degrees. You just want to make sure that whatever you're working with in a particular problem, that your calculator is set accordingly. Okay, so here we have a part on the unit circle, and we can talk about how cosine and sine are defined sort of in this way. Now, this theta here corresponds to some point xy on the unit circle, right? Now, whatever point that is, we're going to define the x value to be the cosine of that angle and the y value to be the sine of that angle, okay? Now, if you can understand sort of this relationship, that the x value is represented by cosine of theta and your y value is represented by sine of theta, that is a big part of the battle of trigonometry. Okay, so that's what these two definitions here are saying. If we're looking at the cosine of an angle, that means that we're looking at the first coordinate, which is the x coordinate, of the endpoint of the radius on the unit circle. And if we're looking at the sine of an angle, right, which is denoted with the three letters SIN and cosine is COS, of course, that's the second coordinate, which most of the time we associate with y, right? And that's the y value of the endpoint on the unit circle, okay? And a nice way to summarize this is that the endpoint of the radius of the unit circle corresponding to theta, of course, if your theta is in radians, is the point cosine theta sine theta. All right. Now, as long as your calculator is set to degrees, you could also do this for degrees as well, but most of the time we assume that this is in radians. Okay. Now, first of all, let's talk about what cosine of pi over 2 and sine of pi over 2 are. All right. Now, again, if you were not familiar with radians just yet, we could say this is 180 over pi. And then if we convert this to degrees, our pi's will cancel, and we get 180 over 2, which is 90. Okay, so this corresponds to 90 degrees. Okay, so if we look at our unit circle, we know that 90 degrees is up here. All right, so we're looking at this coordinate right here. Well, remember that this radius is a length of 1. So if I'm on the radius, that means that that has a length of 1, right? Now, my x-coordinate is clearly 0 because I'm on the y-axis, all right? And of course, since my radius is 1, that means that my y-coordinate is 1, right? So my x comma y is equal to 0 comma 1. But since x comma y is cosine theta sine theta, that means that cosine of theta, in this case cosine of pi over 2, is my x-coordinate, which is 0. And then sine of theta, which in this case is sine of pi over 2, is equal to 1 because that's my y coordinate. Okay, so at its very basic introductory level, cosine of an angle is the x value and sine of that angle is the y value that corresponds to that point on the unit circle for that angle. All right, so based on a lot of the points that we've done so far, we could come up with these several examples for our sine and cosine, right? And of course, this is true because each of these are the endpoint that correspond, right? If you looked at the angle for 30 degrees, you get square root of 3 over 2, comma 1 over 2, right? And same for the rest of these. And that's because your cosine, again, is your x value, sine is your y value. All right, let's look at cosine of negative pi over 2 and sine of negative pi over 2. Well, negative pi over 2 is the opposite of what we just did. This is negative 90 degrees, which of course is down here. And on the unit circle, my circles are not very good in this video. But anyway, our x coordinate is 0, and our y coordinate is negative 1 here, since we're below the x-axis. So this means, let's see, I'm using my pencil here. Okay, let's load this back up. Okay, so let's scroll down. Where were we? Okay, so every once in a while, OneNote likes to quit on me for a second. And we were, okay, here we are. Okay, so our x coordinate, of course, is clearly 0 since we're on the vertical axis. And since my radius is 1, oops, we have a negative 1, right? So again, since my x coordinate is my cosine of negative pi over 2 is 0, and my y coordinate is sine of negative pi over 2, which in this case is negative 1. Right? So those are our two trig functions for this angle. Now, one thing you'll notice is the signs of each of these here, of cosine and sine. Now, in the first quadrant, both x and y are positive, so cosine and sine are both positive. In quadrant 2, here x is negative, but y is positive. So then that means that your cosine is negative and your sine is positive. Here they're both negative, so cosine and sine are both negative. And here, cosine is positive because x is positive, and sine is negative because y is negative. Right? So that's sort of one thing that we can also pick up with the signs here. Okay, so let's do a couple more examples. So if we want to look at pi over 4, right, that corresponds, if you convert this to degrees, you'll find that this is a 45 degrees. And here's where we can start to talk about our triangles now, because now we're not on any of the axes here, all right? Now, if we look at 45 degrees, okay, let me draw the unit circle. 45 degrees is going to be right here, right? And when we drop our perpendicular down, let me draw the triangle out here. We have a 45, 45, 90 triangle. So this is 1, this is square root of 2 over 2, this is square root of 2 over 2. All right, and again, this is my x value, and this is my y value. So it looks like we get that cosine of pi over 4 is square root of 2 over 2, and so is sine of pi over 4, also square root of 2 over 2. Right? Because those are the points that correspond to this radius, right? We have square root of 2 over 2 for your x value, square root of 2 over 2 for your y value because of this triangle here. Okay, now let's do 3 pi over 4. Now 3 pi over 4, if you convert this to degrees, you'll find that you're going to get 135 degrees. Now, if this is 90 and this is 180, that means that if I go another 45 after 90, or I go 45 backwards from 180, I'm going to get that this corresponds to 135 degrees, right? Because if you subtract 45 from 180, you get 135, or if you add it to 90, you also get 135. So I'm going to have the same triangle here, right? But the only difference is that now this is a negative square root of 2 over 2, and this is still positive square root of 2 over 2. So for our 3 pi over 4, cosine of 3 pi over 4 is my x value. So this is negative square root of 2 over 2. And my sine is still positive. All right. Now we can talk about cosine. Sorry, let me just write the angle here. So negative pi over 4. So again, in degrees, this is negative 45 degrees. And that would correspond to this angle here. This is negative 45 degrees, right? Or negative pi over 4 radians. So it's the same triangle. Again, this is not really drawn to scale. You see my lines don't match up there, and they should. But this is the same triangle. This is square root of 2 over 2. And so is this. But now this time, this one's negative, right? So I'm going to get the cosine of negative pi over 4, right? My x value is still positive, so this is still positive square root of 2 over 2. But my y value is negative, so sine of negative pi over 4 is negative square root of 2 over 2. All right, and then finally, you can also show that in this quadrant, you're going to get the same angle for negative 3 pi over 4. But here, they're both going to be negative. You're going to get that cosine of negative 3 pi over 4 is negative square root of 2 over 2, and so is sine. Negative square root of 2 over 2. All right, so here you're using the same triangle for all 4 angles, but the difference now is depending on what quadrant that you're in, you're going to have different values, right? Well, different signs, I should say. Okay, so here we want to sketch the radius of the unit circle that corresponds to an angle such that we know that cosine of theta is equal to 0.4, and we know that sine is negative, right? So if sine is negative, that means that y is negative. And if my cosine is 0.4, which is positive, my x is positive. So this means that we are in which quadrant? It means that we're in quadrant 4, right? So we're going to be, wherever we are, we're going to be in this quadrant, because that's where my y is negative, but my x is positive. Now, the idea might be, well, how do we figure out, because so far I have cosine, which is my x value, is equal to 0.4. All right. Now, if my x value is 0.4, then I can do something like this without even knowing what y is. Right? So again, my radius is 1. So 0.4 is going to be somewhere a little bit less than half. Right? So if we were to eyeball it, we should assume that this is the radius. All right, but we can do better than that. We can actually find what sine is, because we know that x squared plus y squared is equal to 1. And x is cosine squared, and y is sine squared. And we have cosine. We have that cosine is 0.4 squared plus sine squared theta. Now, you'll notice that I sort of made this transition in notation here. This is usually the standard way of notating of a sine or a cosine raised to a power. So we say sine squared and then the angle, just to avoid confusion that we don't mean that the angle is being squared. We mean that the entire trig function itself is being squared. All right, but again, we know that this is equal to 1. So now if we solve this thing, 0.4 squared is a 0.16 plus sine squared is equal to 1. So if we subtract 0.16, we get sine squared is equal to 0.84. So then sine is the square root of 0.84. And since we know that this is the negative sign, I would want negative square root of 0.84. Right? And if you enter this into a calculator, you'll get that this is roughly, so this is roughly negative 0.92. All right, so it's fairly close to 1. And that actually looks pretty good with our drawing here, right? So we could maybe estimate that this is 0.4 comma negative 0.92. All right, and this was all using the fact that x squared plus y squared is equal to 1. All right, and they're just reminding that of us here. Since x squared plus y squared is equal to 1, and cosine is x and sine is y, then we also get that cosine squared plus sine squared is equal to 1. And again, most of the time, you'll see this written like this. And this is just to avoid the confusion that we mean we're squaring the entire function, not just the angle, okay? All right, let's do another one of these examples. And then I think, yeah, we'll talk about a couple other things and then we'll wrap this video up. Okay, so now similar example, here we have that sine is 0.6. We know that the angle is between pi over 2 and pi. This alone tells us that we're in quadrant 2. And we want to find cosine of theta, right? So first of all, is cosine positive or negative? Well, if we're between pi over 2 and pi, then we're in this quadrant, quadrant 2, and here cosine is negative. Right, so we want the negative cosine here. But again, we're going to use the fact that cosine squared plus sine squared is equal to 1. And here we know that sine is 0.6. Okay, so we get cosine squared is equal to, now 0.6 times 0.6 is 36, and that's equal to 1. So if I subtract 0.36, I'm going to get 0.64. And if I square root both sides, I do get plus or minus, but we know that we want the negative square root of 0.64. And this would give you a negative 0.8. So from the given information, we can conclude that cosine of theta is equal to negative 0.8. Okay. Now, a couple things that we need to mention here are the following. So we know that cosine and sine each have to be between negative 1 and 1, right? And that's because if you look at the unit circle, the same things hold if you put x's and y's in there, right? Your x value has to be between negative 1 and 1 because that's your radius, right? Let me draw a little example. If you look at the unit circle, you have something like this, and this has an x value of negative 1, and this has an x value of positive 1. And that's the furthest to the left or to the right that you could get. So those are your lowest and highest x values. And now similarly, you can do the same thing for the y values. Up here, y is equal to 1, and down here, y is equal to negative 1. And those two values are the furthest down and up you can get, so your sine has to be between negative 1 and 1. Okay, and of course, this allows us to say that the domain of both cosine and sine is a set of all real numbers. You can plug any angle in there as long as it's a real number, and you'll get an answer back. But the range, possible values to come out of each of these functions, has to be between negative 1 and 1 for the reasons we just outlined. Okay, so this begs the question, what does the graph look like? Well, I want you to focus on 0 to 2 pi for your interval here, right? Now this is, of course, the graph of cosine of theta, because when your angle is 0, you get cosine is 1. When you're at pi over 2, you're down to 0, because that's your x value, and so on and so forth. But then for every 2 pi, you're just around the circle one more time, so you're going to get this repeating behavior over and over again, right? And of course, the sine graph is similar, only these represent the y values. And here, every 2 pi, it's also going to repeat because you're around the circle one more time. All right, so that concludes this video on cosine and sine. Hope you enjoyed, and I will see you next time.